Hello, Mr. Stone here, and we've talked about Z-scores. Today we're going to be talking about Z-tests. Now, there is a good amount of info here. Instead of making a very long video, please feel free to stop and rewind, check something if it does not immediately become clear. I had to do this myself sometimes when I've got a lot of information. I advise you to do the same. It's a good learning habit. All right, so far we've seen that mu is the mean, specifically of a population, okay, of the whole kit and caboodle of everything. Similarly, we've seen that sigma is your standard deviation, again, of the whole thing of your population. Okay? What we're going to look at is for the mean of a sample, okay, of just a selection from our population, as well as for a standard deviation, we're going to use some slightly different terms. Okay, so these are all for samples. Your mean would just be x bar. All right, this is the mean of just a sample, not the full population. This is everything up top. This is just for a sample, just for a selection that you pull out. Similarly, your standard deviation, instead of sigma, we're just going to call this S. Okay? Important vocabulary and terms to know in going forward. In order to determine if a particular group of data is odd, okay? And in other words, if I've got the mean of the population, if I've got my mu, and it is not the same as the mean of a sample, I might wonder what is going on. What is there some sort of weird thing happening here? So, for example, if I've got, let's say that nationwide, okay, that statistics students study 120 minutes per week. Okay, let's say that is the nationwide standard. Let's say that we've got a sample of, let's say I've got 100, or excuse me, I've got 75 students, and in the sample of 75 students, their average is only 115 minutes. Okay, again, this up here, the 120 is our mu. That is for the whole population. This is just for a sample. And we want to be able to see, is this normal? Can I expect this from just a normal group? If I pick any 75 randomly, is this what I would expect? Or is there something very unique about the 75 that I chose? In order to get that, we're going to do what's called a z-test, which is the name of this video. And to get this, we need to know like one more thing here, which we're going to call standard error. Okay, like I said, there are a few terms that we're looking at in this video. Standard error, it just accounts for some of the error that might come from a standard deviation. Okay, in this case, to work with this problem, we're also going to need to know that the standard deviation for the data we've got up here, we're going to say that sigma, again, this is standard deviation for the whole population. Let's say that is 20. Okay, so you've got a standard deviation of 20 minutes. So my standard error formula is just equal to your standard deviation for the population, your sigma, over the square root of the number of items in your sample. So in this case, we said that sigma is 20, and we said that we had 75 students. So if I want to determine the standard error, we'll abbreviate that just as, how about SE? That seems pretty natural right there. This would just be equal to 20 divided by the square root of 75. If you put that into your calculator, you should get 2.31. All right. So 2.31 is our standard error. And we're going to use this in our z-test. We have just about everything now we need for our z-test. So our z-test is actually going to give us a z-score. In this case, z is equal to x bar minus mu over my standard error. And we've got this now. We said that our x bar, that our mean for our sample was 115, minus mu, we said that was 120, that was the nationwide average, over, and we just got our guy right there, which was 2.31. So if I put that into my calculator, that will give me negative 2.16. And you know what? That is a good old z-score. Okay, so if we were to put that onto a normal curve, here is my not the best normal curve in the world, but hey, so it goes. So we'd have, that would be 0, that would be where our mean is. There's negative 1, there's positive 1, here's negative 2, positive 2. With a z-score of negative 2.16, that's going to put our mark right there. That's about negative 2.16. And we're concerned with everything here to the left. Why to the left? Well, if I go back up, I notice that my sample mean is less than my population mean. So I'm curious what the probability is of having 115 or less. So this leads us back to our hypothesis testing. Okay, because the z-test really is a way to do a hypothesis test. My hypothesis is that, my null hypothesis is that there's really this group is normal. There's nothing odd about that. My alternative hypothesis is that there is a very low amount of time comparatively studying for this group. Okay. However, we've got no numbers here. We need to be able to quantify this. We have to set some sort of way to measure it. So I've got this negative 2.16. Okay, so I'm gonna store this right here. Z equals negative 2.16. And we've already looked at the area under the curve. and that is our good old, we can either use a Z-score table or we could use our calculator. And if we look at this area, well, remember we were using P for our area because that determines probability. The area of everything from this point to the left is just P equals 0.015. All right. What we're interested in, what our measure is going to be, we're going to see if something is statistically significant. And that means that we're going to use our last term from this video. We're going to have this thing alpha, okay? Yes, it kind of looks like a fish. If that's how you remember it, you can give it a little fish eye right there. You know, hello. I don't know what fish say. Maybe they just say fish. We are curious if alpha is really our measure of whether a piece of data is statistically significant. We're going to use a threshold of 0.05. This is like 5%. So we want to do 95% confidence that this would be statistically significant. And here's how this works. So what we want to do is we want to set a null hypothesis and an alternative hypothesis. Our null hypothesis is basically going to say that there is nothing really extraordinary going on here, that nothing is abnormal, okay, that everything would be a fit. So we're going to say that in this case that our p-value is going to be greater than or equal to our alpha, and quite often our alpha is going to be kind of the standard to use in statistics is 0.05. So we're going to see if our p is greater than or equal to 0.05. Our alternative hypothesis is that p is less than 0.05. Is there something going on here? Is the probability so small that it is under 5%? That's something weird is going on. So if we look at what our p-value was, we determined that we had a p of 0.015, actually 2. Okay. If we were to look on the distribution here, we'd see it's right over there, and this is going to be less than our alpha. Our p-value is definitely less than 0.05. So if that is the case, then our alternative hypothesis is correct. Our null hypothesis is not. So we will continue to practice this in class. I know this is a lot of information. Look back over some of these things. Think of some questions to ask, and we will clarify tomorrow. Thank you very much for your time, and I hope you have a great day.